Hi, welcome to this video on the OSI model. In this video, I'll be giving you an overview of the 7 layers of the OSI model and the various services at each layer of the OSI model. So what's the OSI reference model? The OSI reference model was necessitated in order to avoid the difficulty of understanding and implementing networks. What do I mean by this? If you consider a network scenario as shown on the left of my screen here, computer A needs to communicate with computer B. So how do we get this to work without any glitches? If computer A is designed by a particular manufacturer and computer B is manufactured by another manufacturer, how do we get the two to speak to each other in a way they understand without any glitches? Now, this is the basic reason why we need the OSI reference model. So you can imagine for the communication to occur between these two PCs, there are a number of activities that need to take place at different times and in a coordinated manner. If each of these activities are delayed in any form or decide to happen simultaneously, communication can be very, very difficult. Hence, there needs to be a strata of processes that needs to be followed in order for communication to be effective. So what exactly are we talking about here now? What the OSI model is trying to achieve is to avoid a situation where chaos is the order of the day. Imagine if all these activities here are happening in an uncoordinated fashion. Communication will become very, very difficult or nearly impossible. So what exactly are we talking about here when we refer to the OSI model? So the OSI model itself is a reference model that describes how communication should occur among network entities. By network entities, I mean devices that are connected together in order to share resources amongst themselves. And the OSI model divides the communication process into 7 layers. We'll come into that in a short while. And it also describes the function of each layer and how each layer interacts with adjacent layers on the model. So let's quickly get into the 7 layers of the OSI model. So what are the 7 layers of the OSI model? These are given here, and you would see from the diagram here that each of the layers are numbered from layer 1 all the way through to layer 7. And what are these layers? There is the physical, data link, network, transport, session, presentation, and application. And each of these layers are referenced by the layer number. So from layer 1, which refers to the physical layer, all the way through to layer 7, which indicates the application layer. And just before we move into the details of this, of what each layer does or the peculiarities of each layer, then we need to just give it a little mnemonic to help remember the layers. Just in case you're seeing it for the first time, how can you commit these layers to heart? There's a mnemonic here. If you're starting from layer 7 down to layer 1, from layer 7 to layer 1, it says, at present, some teachers need Dr. Phil. At present, some teachers need Dr. Phil. But if you're going from layer 1 all the way up there, it says, please do not touch Steve's pet alligator. This would help you to remember each of the layers of the model. So let's start by looking at the application layer. So what exactly happens at the application layer? The application layer is layer 7 of the OSI model, and it is the layer at which applications access network services. So this layer is where your whatever application you are using gets to interact with the network, and it represents all the services that directly support software applications for services such as file transfer, database access, emails, and other services on the network. So basically the application layer is just where your application is connected to the network, and we'll move straight to layer 6, which is the second layer we are considering now. So what is layer 6 of the OSI model? The layer 6 is the presentation layer. So what exactly is unique about the presentation layer here? The presentation layer is related to the representation of transmitted data. It actually translates different data representations from the application layer into a uniform standard format. We talked about the application layer being the point where the software, where your software accesses the network. But when data is to be presented to the network, what format must it be presented in a way that which is going to be uniform across all devices? It is at this layer you find the definition of file formats. For example, you have PDF. They are not just for the sake of fun that we have a document represented in this format. You could bring a PC that is Mac, and then you can create a file in a Mac and send it over to a Microsoft PC. The Microsoft PC will also be able to understand and read the PDF file. So that is exactly what the presentation layer does. It ensures that all data are presented in a manner in which they are unique and everyone can actually understand them. So besides that, it also provides services for ensuring security of transmitted data. For example, you find data encryption and data compression services are achieved at the presentation layer. So let's look at layer 5. Layer 5 is the session layer, and the session layer is responsible for creating, using, and tearing down sessions between applications. If I'm going to make a call through from my PC to your own PC now, you can imagine a session needs to be set up for that call to go through. There must be a link that is established between my PC and yours in order for that communication to take place. And the session layer protocols are responsible for creating that session. Is this communication feasible? These protocols ensure that the communication is feasible first, and then if it passes the feasibility test, they ensure that the link is created between the two entities that intend to communicate. And when the link is set up, it ensures that the link is available until the communication is finished. And once the communication is finished, it tears down the session is ended. So when you are downloading a file or you're sending a file between two devices, the session layer is responsible for creating those sessions and ensuring that the session stays active and is closed when the transfer or the service that you requested for has been completed. Besides this function, the session layer also establishes what we call dialog control. And what do we mean by this? By dialog control, it means that the session layer protocols regulate which side transmits during a communication and which side is going to be on the receiver, and how long should that happen for each of them. When communication is to happen between any two entities, like I said, like in the oral communication, two of us can't be speaking at the same time, and we don't see that kind of communication is effective. You wait, take your turn, speak, then I speak. So when one computer is transmitting, the other is also is receiving. So how do we get that to work? That's the session layer that ensures that the dialogue between any two entities is controlled in such a way that communication is seamless. And then finally, the session layer also perform what we call token management and synchronization. And like I just mentioned here, when you're doing dialogue control to say who transmits now and who is receiving now, that synchronization amongst between the devices among all connected entities is managed at the session layer. So next we look at layer 4 of the model. So what is the layer 4 here? Layer 4 is the transport layer, and this layer is responsible for managing the transmission of packets. When I say packets, packet is the a packet is basically the unit of data at the transport layer. As we go down the layer into the lower layers, we would understand how data is transformed as at different layers of the OSI model. So at transport layer, the data that is being handled is called packets. And what a packet is just a bundle of informations, and such informations which we will see in the next layer are called frames. So it's just like boxes of frames. And how do we send these boxes over the network such that the receiver can receive them in the right way? And then how do you determine how much information is sent in a packet, how much information are contained in a packet, whether it is long or small, how much information are necessary, and how do we transmit these packets safely from the source to the destination network. And then when it gets to the other end, how do we break down these packets, remove whatever form of encapsulation around the data, so that the person who is receiving it can read the information. So it talks about the packaging, at the same time the reassembling of the packet at the destination entity. So if there is any error in the transmission of the packet, the transport layer also handles the recognition of such error, as well as recovery from such error. Again, another important function that is undertaken by protocols in the transport layer is the acknowledgement of packet delivery. When information is sent from a source to a destination, you want that information to be sent reliably, such that the person who it is meant for receives it and gives a confirmation that it has received such information. So when information is sent, the receiving station sends an acknowledgement. So that acknowledgement process is also a function of transport layer protocols. And if there's anything that is missing, the transport layer protocols ensures that such missing information is sent back from the source to the destination. So next we'll look at layer 3 of the model. So layer 3 of the OSI model is the network layer. The network layer manages network addressing and routing of data across various network segments. Let me help you understand this better now. If I'm going to send a mail from Los Angeles in the USA to, let's say I'm sending it to New Mexico. So now, how do I ensure that the mail I'm sending from here gets to my destination? There is one important thing that is required, and that is what? The address. If I get the destination address correctly, then my information is going to reach my intended recipient. So the address here, which is a unique entity, it is a unique one for every household. Every household must have an address. And so if the address is unique, then you can be guaranteed that your information is going to reach the expected destination. So every host on the network is to be assigned a particular address. I'm sure you've heard the word IP address. An IP address is basically a, a unique identity given to every entity on the network. Every computer connected to a network must have an IP address, which is a unique identifier of that device on the network. So the network layer is in charge of the management of the network addresses. How do you assign network addresses to each entity on the network? The network and the management of such addresses, network layer protocols are responsible for that. Again, there is what is called the translation of logical addresses and names into physical addresses. That's a very pretty one. If you go, let's say for example, you are going to use your email and you use yahoo.com. Yahoo.com is basically a name, but on the network, the computers understand what the network understands is basically IP address. So, how do you translate this website into an address that the internet understands? Each host on the internet uses an IP address. So, how do you translate this? You just type in on a URL yahoo.com, but this yahoo.com is pointing to a particular host, and every file you click on that website is linking you to a particular document on that web server or something. So what the network layer is also responsible for is the translation of those information, the for example the URL or whatever, into a logic into the physical address, the physical address of the intended resource that you that or the intended host that you want to communicate with. And also, when you have a host in a very large network that needs to communicate to another host in another network entirely, how do you ensure that your information is sent in a timely manner, either within your network to the from a source to destination, or outside your network if the source is outside your your own network? How do you ensure that information goes from there? How do you find the best path for the information to travel before it reaches the destination? So the network layer protocols are responsible for what you call finding the route. What you call is a process called routing. So network protocols are in charge of the routing of information amongst networks. So the routing itself is a very interesting part of networking that if you decide to take a career in networking, you will find it very interesting. So another aspect that network layer handles is, like I mentioned, the routing as well as the switching function. Switching is a layer 2 function, and you see that it continues the course of networking. So, and when there is congestion at any port, how do you manage that? You have information coming at a rate uh, that the ports cannot handle. So, how do you ensure that you manage those packets such that the information is not lost? Is not lost in the process. So, when you talk about routing, the sending of information from one segment of your network into another, you can do it basically through a static routing process where you state all the source and destination networks, the source and destination networks, and the path to all these networks are stated in a routing table, static tables. And it could also be such that you determine the source and destination addresses from the beginning of any session, or maybe each host on the network determines individually what the path to is what the path to the destination is, to each destination on the network is. So that's that's a unique function of the network layer. So next we'll look at layer 2 of the OSI model, and this layer is the data link layer. Like I said, this is layer 2, and this layer is responsible for the creation of frames. Frames are created from the raw bits zeros and one that are generated from layer 1. We know that informations are usually sent in binaries, zeros and one, and when they are generated in zeros and one, they are sent as electrical signals, pulses over physical wires to destinations. Now, the zeros and ones, the bits that you sent from your from the source, from the source, for example, maybe your voice, they are packaged into what you call frames in layer 2. So data link layer is responsible for organizing those bits into frames, and the frames eventually are what are grouped together to become packets that we talked about in layer 3. So the data link layer also ensures reliable transmission of frames. The grouped bits are reliably transmitted over the network. So, like I said, there is also what we call the acknowledgement of receipt of transmitted data, which in this case we're talking about frames from the destination. So, when you talk about reliable communication or reliable transmission, you're talking about the transmission and acknowledgement of receipt of such information by the recipient. And if there's any problem in the transmission of such, if the information is not complete, it ensures that such missing information is retransmitted from the source until an acknowledgement is reached. So that's just a brief about the data link layer. So let's quickly look at the last layer, which is the physical layer. Like as the name implies, it is the physical layer, the transmission of bits from one computer to another. And like I said, the bits are basically electrical signals, electrical pulses sent over wires from one device to another. And this layer, all the protocols at this layer regulate the transmission of the streams of bits over the medium. How do you get to transmit the zeros and one, the pulses over electrical devices? What kind of cable would you be using? Is it a fiber optic cable? Is it a twisted pair cable? Copper cable? Is it coaxial? Is it going to be fiber optic? What kind of cables are you going to be using? These are physical layer issues. And then what kind of connectors would you be using? How many volts would represent your 0? How many volts represent your 1 in binary? So these are issues that are related to layer 1, and protocols of layer 1 protocols are responsible for handling of this. Again, it's also one of the things layer 1 issue protocols deal with, is to say whether the channel is going to be simplex or duplex. In simplex communication, information can only go in a one way direction. It's just one way. It's just like you holding a pipe and you speaking into the pipe. The information goes out on the other end of the pipe. But when you're talking about a dual communication, duplex communication, is one in which communication and along the channel can go simultaneously in both directions. Like when you're talking on the phone, you can hear the other person while you're also speaking at the same time over the channel. And what kind of connectors are you going to be using? Are they RJ45 connectors, just like the one you find on your network cables, or they are going to be using fiber optic cables? And what kind of pins, and what is going to happen on each pin? If you look at a network cable, for example, you have 4 pairs of wires there, 4 pairs of wire. And what is going to be the function of each of these wire? Is this going to be with this pin here? Would it be for acknowledgement? Would this be for transmission? Would this be for reception? Is this for some control signal? So the physical layer protocols deal with the functions of all the entities on the physical level. So we quickly move down to see a comparison between what we call the IP protocol stack, and compare it with the OSI model. The OSI model. As you would remember when we started, the OSI model has got 7 layers, but the TCP/IP block has got only 5 layers. And you will find again that the layers here on the protocol stack have been collapsed into a single layer on the IP protocol stack. So what do we mean by this? there is an explicit presentation layer. The presentation and session layers here, they are explicitly missing here in the IP protocol stack, and that data link and network layers are designed. If you look at these two, they somewhat overlap in this case. So they are could be designed into the network interface as well as the internet protocol in this case. So this is just a basic we'll probably go into this in more details in subsequent videos, but more importantly, we just want you to see what the distinction is between the IP protocol stack and the OSI model. So we quickly want to look at what the services in the OSI models are, and you look at each of the layers as they overlap. You find that we've seen that each layer performs a particular function. The protocols of each layer are meant to perform a particular function, but there is something that we need to understand, and that is that each layer provides services to the layer above it and consumes services produced by the layer below it. For example, if you look at the layer 2 and layer 3, layer 2 produces frames, and the frames are consumed by what? By layer 3, because layer 3 consumes them to produce packets. But when you look at, if you take it the other way around, the packets which created by received by layer 3 are encapsulated, and the frames are received at layer 2. What this layer produces is consumed by this other layer, and what this other layer produces is consumed by this other layer here. Active elements in a layer are called entities. The elements of each layer in a particular layer, we'll call them entities. And the active entities in each layer on different machines are called peer entities. So if a machine here is to communicate with the machine here, so the layer 2 devices here, or layer 2 processes here, and layer 2 processes here are basically entities in that layer, even though they are of different machine, but they are actually on the same layer basically. So finally, just before we end this video, I just want to give simple definition to some basic terms, and that includes what a service is and what protocols are. So basically, services are defined as what layers can do. The function it to perform is actually what the service is, and it does not say how it does it. We are not dealing with how the services are performed, but what exactly can that layer do. For example, when it comes to IP addressing now, we'll say a layer 3 protocol can provide help with IP addressing, but we're not actually looking at IP addressing is a service, network addressing is a service, but how it does that is something else entirely. And then when we talk about the protocol now, the protocols now, every protocol is basically a set of rules that governs how communication takes place between peer entities. Remember what the peer entities are. What a layer 3 device on this side and a layer 3 device on that side, when the communication is going on, information on this layer, how is it read on the other layer so that communication can occur. So this marks the end of the video, and hopefully in the next video I'll deal with IP addressing and other network addressing related subjects. Thank you for watching.